I'm Anil Kumar sharing with you a test paper on first 4 chapters of vectors. We already had a quiz on this. Now here we'll have 2 parts in the test paper. This is part A. In part B we'll take up application and communication questions. The 4 questions here are: question number 1. Unit vectors u and v have angle of 30 degrees between them. Sketch the vectors 2u minus v. Part B is determine the magnitude of 2u minus v, and C is for what condition can u plus v equal to 0. So I should write 0 vector here. Question number 2 is unit vectors u, v and w that are non-collinear, determine the condition for the sum of these 3 vectors to be 0 vector. Question number 3 is vector AB has endpoints A minus 3, 1 and B is 1, 3. Determine the coordinates of point C if AC equals to 3 times AB. Question number 4. We are given a parallelogram here. For the diagram, write PQ in terms of A and B. So the A is from A to B and vector B is from A to P, and P is the midpoint of BC. Right? So these are the 4 questions for you. You can pause the video, answer these questions, and then look into my suggestions. Now let us look into the solution of each of these questions. Question number 1. Unit vectors u and v have angle of 30 degrees between them. Sketch the vector 2u minus v. So what we are given here is a vector u, let us say, and a vector v. The angle between them is 30 degrees. That is what we are given. Now what we need to do here is to sketch a vector 2u minus v. So let's sketch 2u minus v. 2u means that the vector will be in the same direction as u, but twice the magnitude, right? So on this scale we can say this is 2u, right? So that is u times u. So length is twice. Vector v remains same, minus v we have to figure out. So we'll say this is vector v for us. So we have here 2u and this is vector v. Now what is the vector 2u minus v? So 2u minus v will be vector which will be from here to there. 2u minus v. Is that clear? So this is the vector 2u minus v. So that is part A. The angle between u and v remains 30 degrees as it is given to us. Part B is determine the magnitude of this vector. So to find the magnitude of 2u minus v, we can apply cosine law. So we can say magnitude of 2u minus v is equal to square of these two magnitudes, magnitude of v square plus magnitude of 2u square minus 2 times magnitude of v, magnitude of u, 2, let me write 2 now here, okay, cos of angle between them, which is 30 degrees. Perfect. So the magnitudes are 1 since we are given unit vectors. Correct. So magnitudes are 1. So we have 1 square plus this becomes 2 square minus 2 times 1 times 2 times cos of 30 degrees. Correct. So let's use the calculator, and now so square root of 1 plus 2 square is 4, minus 2 times 2 times cos of 30 degrees is equal to 1.239 something, right? So let me approximate this to 1.2. So that becomes the magnitude of 2u minus v. Correct? So that is our part B. Now let's look into the third part, which is for what condition can u plus v equals to 0? So as you can see, u and v are at an angle of 30 degrees. So for C, u plus v equals to 0 vector is not possible. Right? So since we have angle of 30 degrees between them, right? Since they are at 30 degrees, right? This could be possible if we were considering two vectors which were kind of like this. Do you see that? So then it was possible. Is it okay? So if you have vector A and vector B, and let's say their magnitudes are unit vectors, then it was possible for two vectors. Not in this case. So I hope that is clear, right? Now let's look into the second question, which is kind of related but interesting. It says, unit vectors u, v, and w that are non-collinear, that means they are not along the same line, they are given to you, are given. Okay. Determine the condition for u plus v plus w equals to 0. Is that possible? So what we just saw, that u plus v cannot be equal to 0 vector. However, if we have three of them, can we have 0 vector? Now this is a very important question to understand. Now this is possible. The answer is yes. Can you tell me how? Now this is a very good question. It is possible if you have, let us say, u vector, let's say this is my u vector, and somehow if I'm able to make a triangle which could be kind of like this, that's the second vector, and if the third vector returns to the same position, in that case you can see that sum of u, v and w is equal to 0. Is it okay? So if you can form equilateral triangle, then it is possible. Do you see that? Only then it is possible. Now if we form an equilateral triangle, then the angle between u and v should be this angle, 120 degrees. Do you see that? Angle we always measure when we place tail to tail. In this case also the angle between these two vectors is 120 degrees. Right? So the answer now is very clear that yes, if u, v and w can form an equilateral triangle, so that means the angle between them is is 120 degrees as shown in the figure, right? So is that clear to you? So this is extremely important question, seen so many times in test papers. I hope that will help you, right? So now let's look into question number 3. Says, vector AB has endpoints A minus 3, 1 and B is 1, 3. Determine the coordinates of point C if AC is 3 times AB. So let's sketch it just to give you a better idea of the whole thing. So what we are given here is vector AB whose point is, let's say, minus 3, let's say this is 1, 2, 3 and minus 3 and 1. Okay, so that becomes the point. And B is 1 and 3. Let's say this is 1 and let's say this is 3. Okay. So the vector AB we're talking about is this vector. Perfect. Where point A is minus 3, 1 and B is 1, 3. What we want is a point C, which is 3 times. That means it has to be collinear, right? So let's say up to this point. Okay, so this gives you the vector C, and we don't know what those points are. We need to find this point of vector C. Is it okay? So as per the diagram, they have to be collinear. Only then we have AC equals to 3 times AB. Perfect. How do you find this point? One of the easy ways of finding this point is to look at the position vectors, right? So we know the coordinate points. Whenever you have coordinate points, you can think about joining them with the origin, so you get position vectors. Is it okay? So look at this diagram. So this is position vector. Is it okay? Okay. OC. So we have now position vectors. So whenever you have from the origin, they are called position vectors, right? OA, OB, and OC. Perfect. These are position vectors. Do you see how they are related? Let's figure this out. We want to find what OC is, right? So OC, we need to figure out what it is. OC is OA plus AC. Is it okay? Plus AC. Now we know AC is 3 times AB, so it is OA plus 3 times AB. That is what OC is. What is OA? Coordinates of it, because that is minus 3 minus 0, 1 minus 0. So get the same point. So I'll write this as, let me write like this, minus 3 and 1 plus 3 times A to B. Now A to B will be, this is B is 1, 3, right? So A to B is how much? So B x values is 1, so it is 1 minus 3, then 3 minus 1. 3 minus 1. That is A to B, right? So when I say A to B, then basically it is x values difference, like difference of x values and difference of y values. That is what it is, right? So that is what we have written here. So that gives you minus 3 and 1 plus 3 times. That becomes 4. This is 2, right? So that could be written as minus 3. 3 times 4 is 12. 1 plus 6, right? So which is 9, and 6 plus 1 is 7. So that is how we do vector addition when you're given the coordinates. So that gives you the coordinates of point C directly, right? So therefore, C point is 9, 7 for us. Is it okay? So that is how we are going to solve it. So it is a very interesting way of doing it, and I hope at this initial stages, if you learn such methods, that will be very good for you. Now here is the last question of this first part, part A. Question 4. For the diagram, write PQ in terms of A and B. So we need to write PQ in terms of A and B. Now we are given a parallelogram, right? So we have a given A, B, C, Q, right? So that's a parallelogram given to us. So opposite sides are parallel. P is the midpoint. P is midpoint of BC, right? So that's why we are saying that these two sides are equal. And these arrows indicate that it is a parallelogram. I hope it's clear, right? Now, we have to find PQ. What you could write PQ as? PQ could be written as AQ minus AP, right? So we can write this as AQ minus AP. Minus AP. That is how you can write PQ as. So this minus that. Now AP we know is B, but we have to write AQ in terms of A and B. That is what it is. And we know AQ is actually equals to BC, right? So we can write this as BC minus AP. Okay. Now these two are parallel sides, and that is why they are in the same direction, and their magnitude is also same. So they are same vectors. Now BC could be written as twice BP minus AP, right? Now here, what is twice BP? B to P is how much? B to P is twice. Let me write in terms of vectors. We are saying B to P, this direction, is B minus A. Is B minus A. That is twice BP. And what is A to P equals to? A to P is given to us as B. Do you see that? So that is what we get. Now let's open this bracket. So scalar multiple, we get 2B minus 2A minus B. And that gives you 2B minus B. Let's rearrange commutative property. So that's kind of a review on properties. 2B minus B is just P. And then we have minus 2A. So we have written PQ in terms of B minus 2A. So that's the answer. So P to Q is equals to B minus 2A. So I hope the steps are absolutely clear, right? So that gives you some kind of review on the first 4 chapters which we did on vectors. In part B, we'll take up application questions. Feel free to write your suggestions and your views. If you subscribe and like my videos, that'd be great. Thanks and all the best.